See this question. The spherical surface of a plano-convex lens of radius of curvature 1 meter is gently placed on the flat plate. The space between them is filled with transparent liquid of refractive index 1.55. The refractive indices of lens on the flat plate is 1.5 and 1.6. So this is the let me draw it a red. This can be the flat plate and this is the lens. Now the space between them, space between this flat plate and the lens, we are filling it up with a transparent liquid of refractive index 1.55 and refractive indices of the lens, that is 1.5 and this is 1.6. This is exactly the same case which I discussed in previous lecture. The radius of it says the radius of 16th dark Newton ring in reflected light of wavelength lambda is equal to √5 millimeter. Determine the wavelength lambda in microns of the light. Here in this case, see, if a light is falling on this, you have a ray of light getting reflected and you have a beam of light getting reflected from the lower surface. So here the path difference comes out to be 2 mu t. See, both rays are suffering a phase change of pi. Both rays are suffering a phase change of pi. So the path difference will become 2 mu t. Both the path difference, mu is optical path distance. Optical path difference will be 2 mu t. Difference in the optical path traveled by them will be 2 mu t. For minima, it should be equal to n minus half lambda. For minimum, it should be equal to n minus half lambda because it's talking about dark ring. So, and 2t is rho n square by r into lambda. So that will become, rho n will become n, this will be n minus half lambda r upon mu, right? Radius of nth dark ring is going to be n minus half lambda r upon mu. Just put the value of mu is 1.55, n will be for 16 dark ring, n will be 16, n equals to 1 will correspond to first dark ring, so n equal to 16 will correspond to 16th dark ring. So this will come as, suppose I put this value over here, I love all this, yeah. Now this is n minus half lambda r upon mu is going to be rho n. So for 16 dark ring, I'll put n equal to 16. So that will come as 15.5 into lambda, r is 1. So 1.55 equal to √10 millimeter, √5 millimeter. This is √5 millimeter. So if I square this, I'll get 10 lambda equals to 5 into 10 to the power minus 6 meter, or lambda will be 5 into 10 to the power 7 meter. This will be the value of lambda. This will be the value of lambda. Now the question says, if the liquid is removed, we have got the value of lambda. Question is, now the transparent liquid is completely removed from the space between lens and the flat plate. Find the radius of 20th dark ring in the reflected light after this change. I remove this liquid. Now they are asking you, what is the radius of 20th dark ring? 20th dark ring. If you remove the liquid, the path difference now is 2t plus lambda by 2, because this ray number 2 will suffer a phase change of pi because it got reflected from rarer to denser interface. So this will be air. This will be air, right? So path difference will be 2t plus lambda. Apart from traveling a distance of 2t, it will also travel a distance of lambda by 2. That is due to phase change, pi phase change upon reflection. And for minima, this should be n plus half lambda. So that gives you n lambda, and it is rho n square by r n lambda, or radius of the dark ring is n lambda r. Now they are asking me radius of the 20th dark ring. Radius of the 20th dark ring. So n equal to 0 will correspond to a dark spot over here. N equal to 1 will correspond to first dark ring. So just put n equals to 20. That will give you the radius of 20th dark ring. And lambda is 5 into 10 to the power minus 7 into 1. So that comes out to be, it will come out to be root 10 millimeters, right? So root 10 millimeters.